One of the later steps in data management is evaluating whether you might want to create secondary variables. Secondary variables are variables that include information from two or more primary variables. We can create secondary variables by using a mathematical or logical operation on two or more variables. In this case, we want to know the number of cigarettes smoked per month. We know the number of days smoked each month, and a new variable, US Freak MO, gives us an estimate of the quantity smoked. If we want to estimate the total number of cigarettes that participants smoked per month, it would make sense to multiply these two variables and get a product that represents the number of cigarettes per day times the number of days smoked per month. Let's call this new variable numsigmo_est, which stands for the estimate of the number of cigarettes smoked per month.
So the syntax would look like this. How can we check to make sure that this new secondary variable was created as we intended? For this, we're going to use a new statement which allows us to subset our data frame to only those variables we'd like to display. We will call this new data frame sub3, and we will ask that it include the following variables from the data frame we have been working with sub2. IDnum, our unique identifier, as well as the frequency and quantity variables that were used to create the estimate of the number of cigarettes smoked per month. We also include this new variable numsigmo_est. Next, we will ask Python to display data from the new data subset by using the head function and asking for the first 25 rows or observations. This includes the code sub3.head with the number 25 within parentheses. So let's save and run this program. The rows we see represent individual observations similar to the dataset itself, and the columns show the values for the specific variables. Looking over these values for a handful of individuals, we can see that, in fact, our secondary variable does show the value of number of days smoked per month times number of cigarettes smoked per day. For example, for the participant with an ID number of 21, 3 cigarettes per day was multiplied by smoking frequency of 30 days in the last month, resulting in an estimated 90 cigarettes smoked per month, and so on. Remember that whenever you're conducting data management, it's important to find a way to check for errors at each step of the process. Then we add syntax to retrieve our frequency distribution.
So what if you want to combine more than two variables? A good example of this would be creating a single secondary variable to characterize ethnicity from a number of separate primary variables available in the AdHealth data.
In AdHealth, race or ethnicity are measured by a series of questions, coded 1 if yes and 0 if no. Since adolescents in this sample could have indicated more than one race or ethnicity, we could decide to characterize those adolescents who indicate multiple racial or ethnic groups separately from those who could be characterized with a single ethnicity.
Let's turn to a program that will load in the AdHealth data so we can work with its ethnicity variables. The only syntax currently in the program is importing the libraries and loading the data set. Now we want to work with the race and ethnicity variables. To accomplish this, the first thing to do is sum the variables to get a new variable, which we'll call numethnic, that indicates the number of race or ethnicity variables that were endorsed. Because I'm going to sum them, again, I first need to make sure that they're numeric. This code will accomplish that. As always, we need to set aside the missing data, which here includes setting both the codes of 6 and 8 to NaN so that they are not included within our new ethnicity variable. Now I can include a statement to sum these individual race ethnicity variables into a new variable, which I call numethnic, that indicates the number of race or ethnicity variables that were endorsed. Here's the code that creates the variable. and the code to examine the frequency distribution. We use the define function, shown here as def, D-E-F, to create a new variable called ethnicity. The row code defines a temporary variable to be used in the function. Then we use the apply function to actually create the new variable in the data set. Axis equals 1 tells Python to apply the function to each row. Note that the lambda operator or lambda function is a way to create small anonymous functions, that is, functions without a name. These functions are throwaways, that is, they are just needed where they are created. Lambda functions are commonly used in combination with the functions filter, map, and reduce, but here we use it within the apply function. So if numethnic is greater than 1, the new variable ethnicity will return a 1, indicating multiple racial or ethnic groups endorsed. Other levels of ethnicity will be coded based on each race ethnicity variable. So if H1GI4 equals 1, then ethnicity will return a value of 2, which means only Hispanic or Latino ethnicity was endorsed. If H1GI6A equals 1, then the ethnicity variable will return a 3, only Black or African American ethnicity was endorsed. If H1GI6B equals 1, then ethnicity will be 4, only American Indian or Native American. If H1GI6C equals 1, then ethnicity will be 5, Asian or Pacific Islander only. Finally, if H1GI6D equals 1, then ethnicity will be 6 for white only endorsed. When we add this syntax to our program, we'll also add statements to print these variables to the console for the first few observations and show frequency distributions for the primary, that is original, and also the secondary ethnicity variables, that is those variables we've created. To do this, first I define a data frame with only the primary and secondary ethnicity variables, along with the unique identifier from addHealth, which is AID. Next, I use the head function to request the first 25 observations in this new data frame. Finally, I include value count statements to request frequency distributions for each of these variables. So here we see the output, showing the original and newly managed ethnicity variables for the first 25 observations, in this case, the first 25 adolescents in the addHealth dataset. And later in the results, we can examine the frequencies and percentages for these variables. We've made this program available to you. We suggest you copy the script, open it in Python, and run it. Examine the output and consider how this kind of data management might be useful in answering your questions with your dataset. This example should help you make the needed connections between data management decisions and code.